Problem solving here. So we looked at problem solving in chapter 1 in sections 1.8 and 1.9. We're really going back to that concept. But no longer are we solving problems, we're coming up with solutions of sets of solutions or ranges of solutions. Okay, that's why we have inequalities. If you remember that we talked about the whole idea that inequalities give us ranges of values as answers. Let's first identify inequality word problems. Remember we talked about this on that first day? At least, at most, no more than, no less than. Those terms, when you see these terms here, they're in quotes. When you see those words, you have to think inequality. Okay, you have to think inequality right away. So this is a little, let's see, like a small test-taking strategy for subject tests or for your SAT. For any standardized test in math, when you see at most, it means something less than that value, at most. Okay? The first example. Alex, read it for us. Miss Lau, please. You can read it off the board. It's fine if it's not up yet.
A store charge $5.50 each for calculators and a delivery charge of $25 for the order. If the store sells the calculators for $8 each, how many must be ordered and sold to produce a profit of at least $86?
So this could be a regular word problem, not an inequality word problem if it didn't say at least $86, right? It could say, how many must be sold in order to produce exactly $86? Well, then it's an equation. But since we're looking at an inequality, it says at least. So let's begin. Let's talk about this concept and let's relate cost and profit and revenue and what this stuff means. So first of all, we think about this and we could say, what is the store paying? How much is the store actually paying for whatever item? It could be, tape cassettes. It could be anything. It could be CDs. It could be, iPods, whatever it may be. What is the charge the store is accruing every time it sells something? You kind of went up with James, huh?
Oh, me?
Yeah.
Well, it could be $5.50 per calculator, and then you add 25.
So how would I write that mathematically?
550x plus 25.
Yeah. So right away, this is what I have for cost. $5.50 per calculator, where X is the number of calculators, and $25 for the delivery charge. So we could say the cost function, right? Cost. And at the top, maybe we want to let X be equal to the number of calculators sold. Now, this is assuming they're selling all their calculators, right? They might not have like a backlog of inventory. What is the profit for each calculator? Or not profit, what is the, I shouldn't say profit, what is the revenue for each calculator? Not profit, they're different things. Anybody know what the term revenue means? What does the term revenue mean?
Isn't it the money you start with?
Not the money you start with.
The money you gain.
The money you gain. So even though you are putting up all this money up front for cost, you gain $8 every calculator. Now, you don't really gain that in profit, but revenue is not profit. Revenue is literally how much money comes in to the store. Profit is revenue minus, what is profit? Revenue minus the cost. So the revenue is $8 per calculator. So every calculator sold, the clerk at the store, the cashier at the store, literally says, okay, give me $8, thank you, have a good day, right? And every time that happens, they make money. Well, that's our goal, is to figure out how much money they're making here. So our goal is to figure out the profit. So let's go ahead and say that profit is equal to the revenue made minus the cost. If you want to write these words down, you can write the word profit. It's fine. Write the word revenue, R-E-V-E-N-E-U-E. Now, what was our problem, though? Our problem says, how many must be ordered so that we produce a profit of at least $86? How do I write that statement? How do I write that statement? I want the profit to be at least $86. Think about the chapter 2 topic of inequalities and how that relates to this.
Profit is greater than or equal to 86.
Exactly. Profit must be greater than or equal to 86. But profit is revenue minus cost. So revenue minus cost must be greater than or equal to $86. Okay, again, yes, Inigo is absolutely right. And this is what we have right here. But since profit is revenue minus cost, I use the substitution principle from chapter 1. And we substitute revenue minus cost in for the profit right here and set that greater than or equal to 86. I can't explain or I can't emphasize how many college students are going to get this stuff. So when I was at Nova, I studied engineering, but I did a lot of tutoring on the side, and I tutored a lot of business students in economics and all their math courses and their business math courses. And the concept of profit being the money you make minus the money you put out is your profit is something that is just sometimes very elusive to people's minds in college. And I don't know why that is. So if this isn't clear, please ask me. I'll go over another way of explaining it. I assume that this is obvious because I've taught this so many times. But if it's not, if this doesn't make sense, this concept of like me walking up to the store and saying, all right, here's $8, but it costs you $5.50 for that calculator, and the $25 to ship it there, so you have to subtract all that in the end, this whole idea of making $86. Okay, your revenue is the money that comes into the store, the cost is the money that goes out of the store. Whatever's left over at the end of the day has got to be profit. Okay, that's how much money you make. All right. Now, with that statement made, let's go ahead and plug in our functions for cost and revenue. The revenue function is 8x. The cost function is 5.5x plus 25. And that needs to be greater than or equal to 86. So again, substitution principle. And we talk about this in chapter 1 and we kind of laugh, right? Like, oh yeah, substitution. You're literally substituting an equivalent expression. Well, this is where it comes in again. Cost goes in right there. Revenue goes in right there. So we've got those two values that are, or those two expressions that are going into our inequality. And now what we can do is solve. Why is it important that I put parentheses? I use parentheses, and I actually overemphasize them, right? I don't need parentheses around 8x, clearly. The 8x does not need parentheses. But why is it important? Why is it important that you put parentheses over here? Sarah? Exactly. The $25 that cost you for shipping should be a negative quantity, right? Because you're losing that money. So yeah, it's going to be negative 5.5x, but this should also be a negative 25. So this negative needs to get distributed. So let's go ahead and distribute that negative. We'll combine like terms. 8 minus 5.5 gives us 2.5 x. I'm going to move the 25 over. All right, I'm going to add 25 to both sides. It's going to give me 111, I think. Then divide by 2.5. What do you get? X greater than or equal to what?
I got 44.4.
Yeah. Now, Jeffrey, I want you to continue this question, all right? And answer, can we say that there are 44.4 as our answer? Is that reasonable? So at least how many calculators do we have to sum?
45.
45. All right? Look at the solution set. The solution set says x is greater than or equal to 44.4. But you can't have 0.4 calculators. So at a minimum, you need to sell 45 calculators. Okay? Again, our answer is 45 calculators. So we take a little bit of problem solving, a little bit of simple algebra, and then relate common sense to it. We say you can't have a calculator, so what must you sell? Because if you sell 44 calculators, you're just going to miss that $86 profit. You're going to be under for sure. Because this tells us we need to have greater than or equal to 44.4. So 45 is the next integer greater. Okay, so your statement might say, and this is where you answer with a verbal statement. Remember on the test I wrote verbal statement? So you'd say, you need to sell at least 45 calculators. That would be your verbal statement. You need to sell at least 45 calculators. Any questions on the first of the 4 problems we're going to do today? Okay, let's look at the second one. This is not easy. This problem. I want you to try and wrong to come up with at least a setup. I'm not asking for an answer. Come up with a setup and the inequality that you're going to use. Now, hint, this is going to relate to yesterday's lesson. Back to yesterday's lesson when we did with compound inequalities. Inigo, look on with one of these guys, maybe slide over. Especially because it's going to go over yesterday's lesson. You want that here for. Call me over when you think you have the right expression ready or inequality ready before you start solving anything. I'm going to give you one hint, not including 20 and 30. I should have put exclusively. Not including 20 and 30. In the test, it will say exclusively. I should have put that word. Not inclusive. No, it's only expression. Good. Now stop. Very good. Good. Now, that's one way to write it. But you could also write it as a compound inequality with, remember, this thing in the middle, and making those your outside two bounds, you lower your number. Remember how we did it yesterday? Yeah. So do that, and I recommend doing that, just because you need to solve twice. Does that make sense what I'm saying? Good. Now, what I'm thinking, right, is that it's got to be bigger than this number, and less than this number. So when you put these together, you're going to get this 4x plus 12 statement, and you can just write it like this. And then 30 on this. Okay, so it says that this quantity is between 20 and 30, and not including 20 and 30. Over here, gentlemen? Good. Good. Now go ahead and simplify it some.
No.
Close.
Oh, yeah.
One mistake. You all have the same thing? Yeah, there's one mistake. This tells me, right? This has to be less than 20. I want it to be greater because somebody needs to source. And whenever you're going to give a range of values from lower, upper, you're always going to use less than 6. It's going to be lower here, this for here. Okay? Focus, always. So what we're doing is we're talking about focus. The idea that, like, imagine a solution, right? That you want to go out and buy a pair of shoes. But you don't want to spend any more than 50. But you want to spend at least $30 to buy a shoe. Whatever. Right? So it means that the price of shoes is between $20 and $30 and $50. So you'd say 30 less than shoe price less than 50. So the shoe price is between 30 and $50. Now, the other thing we did yesterday was that it means that could be above or below. For example, if your body temperature is less than 20 degrees, it's going to want to if your body temperature is greater than 100 degrees, it's going to want to cool down. Outside of those ranges, it could be less than 20 or greater than 8 or one or the other. So this is an example where the amount of integers, the sum, is between 20 and 30. So you're right, first plus one is below. And it's between 20 and 30. I would say equal is not the right term.
Less than greater.
Yeah, so x is greater than 2, but it's less than 4.5, right?
Mm-hmm.
Well, what even number is greater than 2 and less than 4.5? Okay. The original statement, right? It says find an even integer. So what value of x is even integer?
Like I studied, but I didn't retain it.
Well, no, the x equals 4. Yeah, x line. Right? What are you getting?
Isn't that
I'll need an integer between those two numbers. 2, 4, 6. 2 is not in there, right? You see that? 4 is in there, 6 is beyond. So x is equal to 4.
Okay, so
Now, if x is equal to 4, you can list 4 integers, right?
1. And then SLI.
List your 4 integers, go to the next one.
And then FLA 2, it would be like that in that order. Yeah. Okay.
Does that make sense? You did just hear us, right?
Yeah.
And your answer is going to be this is 5 4 consecutive integers. So solve problems like these. When you solve them, kind of just like any other. So you first start like getting rid of 12. So let's go back. So you look at the middle part of this share, right? You either do one of two things. You can write this as one inequality, you can write this as another one, solve it separate, or you can start by subtracting both together. Now divide by 4. The question is again, x is even integer by put even integers between 2 and 4 multiplied. So your answer is x. Now remember what the problem asked for, it's find 4 consecutive even integers. So what x is for, list the 4 integers.
Yeah.
So we know that it's
Check this, not yet, but we've done both. Make sure it's the answer. Yeah, if you're number 2, guys, definitely go on to 3. You can go on to 3 for sure. I just want to make sure everybody got number 2 right. What's number 3? Okay. Number 3 is a little tricky. Maybe we'll do number 3 together. I'll give you a minute to keep going, then we'll do that together. Number 2, it looks like we all got number 2 at this point. Mm-hmm. For the whole race, it should be less than 2.5 hours, yeah. struggle with number 3, look at the board, give yourself a hint if you need to. Think about it in pieces, okay? If you're doing well, you keep going with what you're doing. In the beginning of the race, you have a distance and a certain rate. Then at the end of the race, you're trying to figure out what is that rate for the remainder of distance that's left over, and total time should be less than 2.5 hours. That's kind of my schematic of what's given in this work. We'll give you a little bit more time to work on this with somebody next to you. Please keep working on it.
How are we supposed to use the rate 1 or 1?
I have no idea.
The time.
Use that. Come up with it, figure out what you can do with that. You know how much you do it. Figure out the times and then a little more obvious. Okay, so a lot of time. You know, a lot of time stuff, so I want you to spend as much time as you need to solve this. If you need help, let me know if you're stuck. Start with that. That's your starting point right there. If you're struggling with the starting point, think about the time it takes for the first leg of the trip. That might help you. RT. Once you know this time, you know how much time is left for this part of the trip, if this is the total available time.
So there's R. There we go.
So how fast? So we have this 6:30. Why did the rate? Oh, because time.
So wait, hold on. What is that?
So you divide 30 by 1.
Yeah, but then you have to add that to the original hour because it's 102 minutes. 60 minutes plus 42 minutes. Yeah. 1 hour. 60 minutes plus 42 minutes.
So it'd be
So why I
30
get 42
over
or
R.
60 to get
Say again?
that.
It'd be 30 over R.
So you got 1.7 and then you have to divide.
That's T.
Yes, 30 over R has to be less than 1.
When I did that, I got 17, which makes this like, okay.
Oh, you're adding the rates and adding your distance. Yeah, so it takes everything. A lot of you got this amount right here, right? And it takes that long. How long can you do it? So if you're in 28 hours, how much left?
Right.
What's about here?
Yeah. So for the second leg of the trip, time needs to be less than 7 hours, right? So time, solve that D equals RT formula all the time. What do you get?
So that's an hour, so that's an hour and 56 minutes.
Oh, you have to ask. Oh, you forgot.
Generic.
After the first one.
So RT solve more time.
Which
So
is
D over R is the time, right? And how much does that have to be less than what you said? So right, D over R is less than 7. You know
No, I know that.
R2.
I know that, but like, this finish is less than 2.5.
Let's think about it. So an hour.
You just do the backwards. So the rate was 25, so this is R.
I think it's 7.
What?
No, but you have to round it when you yeah. That's 18, I know, but it's less than 2.5 hours.
We
It's gonna be 18,
we
yeah,
have
when you get more.
this to
Oh, no, wait. Oh, yeah, the fact is you'll be going faster. But it would be less than 2.5.
that's what you want. So that's
I wanted to check her again.
This is top 0.8 hours. Now, if the time takes this to 20 hours, how much do you want to do?
Rate. No, fast. So
You know it is the rate. So if you're at the rate, you know. Now, remember, X is really
that's what you want to see.
so any software.
The rate is we'll divide it.
I know. I'm not really sorry.
What's that subject?
So you had the 1.7 from the subtract 1.8 from here, right? So you said that the time it takes 1.7 is the rate of relation. You did 30 over 1.7, you got 17.65. That looks good. I don't know what the number should be, but the work is right.
So,
Yes. That's good.
that's right.
How do you get 1.7? How long does it take for the first part of the trip?
1.7.
And the whole trip can only take how much?
2.5.
Subtract 2.5 minus 0.8 gives you 1.7 hours.
Oh my gosh, we did the
Good. Good, that's right.
We did it so much more difficult.
Let me go over how to do this, depending on where you're at, and see if what you did is the same. So a lot of you did the first part right, and I gave that hint to find the time it takes in the beginnings. I would do this. For the first part of the trip, D1 over R1 is equal to my time. I want to know how much time the first part of the trip takes. I plug in 20 miles over 25 miles an hour, giving me a time in the first leg of the trip of 0.8 hours. Now, if that is true, it means that the second leg of the trip cannot be more than 1.7 hours. So time 2 must be less than 1.7 hours. Where do I get that? I do 2.5 right here minus 0.8 to give me the 1.7. So time 2 has to be less than this. But what's time 2? Time 2 comes about from this formula. Oops, D2. Right, time 2 is really D2 over R2. I'm solving generically. Remember I talked about this? Just solve the formula for variables. So replace this up here. D2 over R2 must be less than 1.7. If I go to solve this is where I'm seeing little hiccups along the way. If I go to solve this, I know what D2 is. The distance left for the trip was 30 miles over R2, and that's less than 1.7. How do I get R2 by itself now? How do I get R2 alone? It's clearly not by itself, right? How do I get it by itself? Alex?
Multiply both sides by R.
I agree to start. Okay. And then what?
And then you divide 1.7 both sides.
Very good. And that's what allows you to realize that the rate is going to be greater than whatever the answer you get is. Look at the way it's written now. R is over here now. This symbol is a less than symbol, but it's if you read it this way, right? But R is on the right-hand side. So R2 is going to be greater than whatever this turns out to be. And that was 17.64. 6.5 maybe. I don't know, to be honest. I'm reading what I have written. 6.5?
If you round it up, it's 6.5. It's like 17.64, but it's much worse.
But should it be rounded up?
Yeah.
Okay. So it said in the question to the nearest mile per hour. So what's your answer then? 18. Okay? But that's how I would approach this problem. Break it up into pieces. You've got the first leg of the trip taking 0.8 hours, which leaves you with 1.7 hours right here for the second leg of the trip. And if we know that's true, we set our time less than that. But time, if we solve any of these formulas, time is d over r. Time is d over r. So d over r, right here, must be less than 1.7, because that's how much time you had left. Switch these two spots. Remember, you can just flip these two. Okay, if you guys are forgetting this, whenever you have something where it's like t equals d over r, you could flip-flop these. Multiply by r2, divide by 1.7. Just switch these positions, and you could use that every time. Any questions on this problem? I'm going to get to that last one now together. This last one is a little bit tricky as well. And the reason it's tricky is because we're using something called an average now, which you know how to calculate an average. So Catherine's second test score was 8 points higher than her first test score. So what should I start with right away? What should I start with right away? What kind of a statement? What is it called again?
Well, I was going to say, let X be Catherine's first test score.
Agreed. This is called a let statement, which is what I was going with. Go ahead, next.
And her second test score would be X plus 8.
Good. So we know it's 8 points higher than the first one. The third test score was an 88. So that's easy. We know it's an 88 already. We don't have to write anything down for that. If she had a B average, which is between 80 and 89, inclusively, meaning including those endpoints, for the 3 tests, what can you conclude about her first test score? So we know average is between 80 and 89. That's our first statement, right? That's how we write between. Now this should become almost second nature after you did a few of these problems. You'll practice more of these tonight. How do you find the average of 3 scores? How do you find the average of 3 scores? Good. I'm going to put parentheses, but I don't need them because these are sums. I'm putting them there to remind myself for a moment that this is an entity itself, but they're all pluses, so you don't really need those parentheses. So let's go ahead and solve this one together. Can I get a recommendation from somebody as to what I should do? What should I do? Christian?
Multiply both sides by 3.
Yeah, multiply everything by 3.
Yes.
Very good. Both sides. I got you. Both sides. Everything by 3. It's going to give us, what is this? 267? And then for Inigo, who was not here yesterday, Inigo, finish this off for us. What should I do next?
Okay, so you just have to subtract 96 from both sides, and I got 144, and on the other side I got 174.
Nice.
Divided by 2.
Good. And then divide by 2. Very good. 171. Be careful. All right, 171?
Yeah.
Okay, divide everything by 2. I get 85 and a half here, and I get 72 over here. So what does that tell us about her first test score, which is what we're looking for? It says, what can you conclude about her first test score? What can you conclude? It could have been what numbers?
72 to 85.5.
Yeah, and if the teacher were rounding, in this case, 72 to 85, believe it or not. You wouldn't round that up. Even though this is a 0.5, you don't round this up, right? Because we're told that our value of x is less than or equal to 85 and a half. So if it was to the nearest point, it would be 85. It would stop it. This would not round up. Remember, shading what this looks like, it goes to 85 and a half. But if you were going to the nearest point on a test, right here's 72, closed circle, all the way to 85.5. The answers are not over here at 86. So if you were doing to the nearest test point, it would be 72 all the way to 85. Okay, again, it doesn't say that, so I agree with you. This is your answer, between 72 and 85 and a half. Okay, and I keep decimals on your test scores. I never round your test scores. I don't know if you noticed that already. Why do you not round? Anyone know? Why don't I round your test scores? Besides the fact that I know math, because I'm a math teacher, but why don't I? What's the math that's in behind it? What tells you mathematically that you really shouldn't round a test score? Have you ever heard of like cumulative error or propagated error? It means this. If I round every one of your test scores, at the end of the quarter, your grade is like a rounding of a rounding of a rounding. So your grade is not really reflective of exactly what you earned. So if you get an 86.5, and you get an 84.2, and you get an 81.7, I use all 3 of those grades, add them up, and divide by 3. So you get the most precise, exact answer of exactly what you earned. Because if you round, and every test you have to round down, that's kind of, it sucks, right? If you get 82.4 on 3 tests, and your teacher rounds, then you're going to get 82, 82, 82. But 82.4 divided by 3, well, that's still 82.4 in that case. But when you multiply by your your category part, like you 70% of your test, you lose that extra little point that you could have gained. So I never round your test because of the fact that there's propagated error. Okay, it's like saying, imagine how many people, I'm going to use something a little more PG. How many people play video games with a shooting involved? Right? And in any video game with a shooting involved, a little deviation with a sniper rifle causes a lot of deviation long distance, doesn't it? It's a propagated error. A tiny degree that it's off by like 0.1 degrees, it's going to be like 20 feet because that's 1,000 feet away. 1,000 feet away, and you're off by a 10 degree of an angle, is going to be 10 feet off. You're not even going to come close to your target. Anybody ever seen American Sniper or any movies where there's sniping involved? That whole idea of propagated error, that's a perfect example. Not very friendly, but it's a perfect example of propagated error. A small deviation here causes a larger deviation later down the road. That's what would happen if you round every test score, really. Okay? Tonight, make sure you 5 through 11 odd, right? Yeah. 5 through 11 odd, and then the mixed review is older stuff. Okay, these mixed reviews. Anybody know what ST stands for? I've done one of these before. In your book, do you remember what it is? It says, yeah, self-test. Okay, so it's not like group exercises. Okay, tomorrow quiz. Quiz on sections 2.2 and 2.3. Remember, 2.3 is 2.2, but you're still working on it for 2.2.